In this example, we're going to solve a rational inequality. And here we have x plus 1 over x minus 3 minus 1 less than or equal to 2. The first thing we want to do is get this in the right form. We want to get all of the terms combined together into one fraction on one side, and we want 0 on the other side. So really what we have to do is a bunch of algebra here. We start by subtracting the 2 from both sides, and that gives us x plus 1 over x minus 3 less than or equal to 0. Now we want to combine that fraction with the minus 3. Well, we multiply the minus 3 by x minus 3 over x minus 3. This gives us a common denominator. Now 3 times the x minus 3 distributed out gives us 3x minus 9 in that second fraction. So we have x plus 1 over x minus 3 minus the fraction 3x minus 9 over x minus 3. We can combine those into one fraction now. And that becomes x plus 1 minus the quantity 3x minus 9. Now remember, when you're subtracting the quantity, you have to add the opposite of each term to remove those parentheses and combine terms. So we have x minus 3x. That makes a negative 2x. We have 1 minus a negative 9, which is really 1 plus 9. That makes the plus 10. So now our rational inequality is negative 2x plus 10 over x minus 3 less than or equal to 0. And now we have it in the form we can work with. We can now find critical numbers, plot them, and test our regions to solve this inequality. Okay, now we find our critical numbers of our rational inequality that's in the correct form. To find critical numbers of a rational inequality, you let the rational expression equal 0. Well, this ends up giving us solutions where the numerator equals 0. In this case, letting negative 2x plus 10 equals 0 gives us one critical number, and that number will be x equal positive 5, because negative 2 times positive 5 plus 10 equals 0. Also, in a rational inequality, a critical number will occur where the denominator equals 0. And here, x minus 3 equals 0 when x equals 3. So there's our second critical number. So we have two critical numbers of 5 and 3. However, the critical value of 3, we use an open circle for this. And the reason we use an open circle is because if x equaled 3, we'd get division by 0, which is not possible. However, the critical value x equal 5 associated with the numerator, if we plug 5 in, we get 0 equals 0. Now that's a solution to the inequality because our inequality is less than or equal to 0. So 5 solves it. So we include 5 as part of our solution. Now we can proceed to the next step, which is to test values from each of these three intervals. Now we choose our test values. First, we test values in interval 1. We pick a test value that has to be bigger than x equals 5. X equals 6 is a nice simple value, so we'll use that. We use x equals 6 and we plug it in to our inequality, and we can use the simplified form because that's a whole lot easier. We plug 6 in to the inequality. We get negative 2 times 6 plus 10 over 6 minus 3. That gives us a negative over a positive. A negative 2 over a positive 3, which is less than or equal to 0. So that's true. Since it's true, we can shade interval 1. And that endpoint, or that critical value, will be included with our solution. Now, in interval 2, we need to pick a test value that's in between 3 and 5. Well, 4 is the logical choice. We could pick 3.5 or 5.5, but 4 is a whole lot easier. We plug it into the inequality. We get negative 2 times 4 plus 10 in the numerator, which is positive 2, over 4 minus 3 in the denominator, positive 1. So we get positive 2 divided by positive 1, less than or equal to 0. Well, that's false, because 2 over 1 is not less than 0. So interval 2 is not part of the solution, so we don't shade it. In interval 3, we have to pick a test value that's less than 3. So we pick x equal 2. We could have also picked x equal 1 or 0, but 2 is a nice easy value. We plug it into the inequality. We get negative 2 times 2 plus 10 in the numerator, which is 6, and 2 minus 3 in the denominator, which is negative 1. This gives us 6 over negative 1, which is negative 6, less than or equal to 0, and that is true. So interval 3 is part of the solution, and we shade. Now note that we do not include the point x equal 3, but we just go up to x equal 3. So this means our solution is x less than 3 or x greater than or equal to 5. And we can write this solution as x less than 3 or x greater than or equal to 5. Or we can use the interval notation negative infinity, comma 3 with round brackets, union with 5 comma positive infinity using a squared off bracket on the interval from 5 to infinity on the left.